Okay, so I'm going to show you three definitions. A lot of folks get their impressions by what you see on TV. Here's what a president of the U.S., a fictitious president of the U.S., but a very widely seen one, on the West Wing TV show said. I happened to see this episode actually a number of years ago. He was talking about his energy policy, and he said clean coal is a term pollsters came up with because it polls higher than regular coal. What we want are real cleaner burning fuels and alternative energy. If you go to the current president's website and look at his energy strategy, something called All the Above, what President Obama talks about clean coal, he doesn't actually define it, but he talks about it as being part of a strategy to take control of our energy future, invested substantially in cost-effective carbon capture and sequestration. And finally, if you go to an industrial website, a group called the American Coalition for Clean Coal Electricity, they actually do have a definition. They define it as technologies that improve the environmental performance of coal-based electricity plants, but they don't really say how much improvement. And they list a number of options, some of which make very small improvements, some of which make larger improvements. So how clean is clean? What we try to do here at Carnegie Mellon is reframe these questions into things that are suitable for looking at through a research program. And so among the questions we try to ask and answer are things like what options actually are available to reduce environmental emissions and impacts of coal-fired power plants, especially these days greenhouse gases like CO2, carbon dioxide. How well do different options work? How effective are they? What do they cost? And what are some of those trade-offs? We also try to look, and this is where technology innovation in a serious way comes in, what's the outlook for new or improved technologies that have lower costs or better performance? And from a policy perspective, what does one need to do? How can we spur the technology innovations, in fact, that are needed to do a better and more cost-effective job? And finally, we use the technical analysis to look at issues of what policies, regulations, and incentives, if any, in fact, are needed to achieve these lower emissions. So what comes out of this research program? A couple of things. One of our research products in this particular domain are tools that we and lots of other people can use to actually evaluate clean coal technologies, whatever it wants to mean in their particular context. So for example, we've developed over years a computer tool called IECM, Integrated Environmental Control Model, that's now being used actually by several thousand people around the world, many of them students, many of the folks in industry, many regulators, to ask and answer questions about performance, emissions, costs, and uncertainties in the context of the issues that they're addressing. Another set of products are various studies that we put out to, in fact, address key policy issues. Here are a couple of examples. The book looks much better in person. This just came out, a couple of weeks ago. Granger and about a dozen of us, both here at Carnegie Mellon and elsewhere around the country, worked for a couple of years looking at legal and regulatory issues concerning a technology called carbon capture and storage or sequestration, looking at what one would actually have to do to make this technology viable. And I've been involved in various studies looking at how one can raise money for large-scale projects just to see if the thing works and if it's really as safe and effective as advertised. So I put on this slide a couple of what I think are key highlights that come out of the research to try to address these questions. I think one of the key findings is that, in fact, there is technology available today that can reduce environmental impacts of coal-based power plants by varying degrees. There are a series of devices, emission control systems, I've called them here, that can reduce emissions of water pollutants and air pollutants quite effectively, 90 to almost 100%, depending on which pollutant we're talking about. There are other technologies, and these are some of the things alluded to in the industrial website, that can also make some improvements, more on the order of 10 to 30%, simply by building power plants that have higher efficiency, using a lot of that waste heat and raising the temperatures and using other technologies that Granger mentioned earlier. We also, so basically if we ask what's standing in the way of getting as clean as possible, right now, large-scale demonstrations of this technology called carbon capture and storage or sequestration, basically capturing carbon from coal-fired power plants and storing it or sequestering it geologically. We need to basically know that this really does work at large scale, that we could address not only technical issues, but issues of public acceptance and safety. We are in desperate need of these kinds of things just to know whether that really is an option. We also need to reduce the cost of that. And finally, widespread deployment of these technologies, as well as many others, really makes no sense and is not going to happen absent a sufficiently strong set of energy and environmental policy drivers that are lacking at this time. So a second set of research questions essentially then is, given that we're currently relying very heavily on fossil fuels, about 70% of our electricity and 85% of all of our energy comes from fossil fuels, what really is the potential realistically of clean coal technologies and moving toward this notion of a sustainable, low-carbon energy system? Basically, how do you get there from here? This is one of the critical set of issues that this institute will be dealing with, because choices that you make and paths that you take are often not reversible, and answers to that question will depend on thoughtful technical and policy analysis. So how do you get some insights about that? Most of the way that's done is through a variety of energy modeling and forecasting methods and studies. What I've shown here are results from 5 different energy models that were looking at future scenarios for US energy development. There are others that look at this globally. And different models give you different answers. There's no single answer to how you get there from here. But what all of these efforts and our best analysis to date suggests is that coal with carbon capture and storage, if in fact you're looking for serious reductions in carbon emissions and dealing with the reality of just how much fossil energy is in use today, not only here, but in places like China and India, this technology of carbon capture and storage is one of the critical components of a cost-effective strategy to get to that sustainable future. It's not the only strategy by any means. Lots of other things are needed, but that is always critical. The other thing that's relatively new is it's not just about coal anymore. So I'd like to coin a term here that says clean gas technologies, particularly if we start taking some of Gene's shale gas and burning that in power plants. Gas ain't so clean as it's often thought to be, and it's certainly not carbon-free. And so just in terms of carbon emissions, this notion of carbon capture and storage on natural gas-fired power plants, which are growing in popularity, is also something that will be needed in this transition to a sustainable energy future. So I've tried to put this together into this little final cartoon that suggests that in fact clean coal as well as clean gas technologies, potentially, if we choose to go down the policy route of actually getting serious about reducing carbon emissions and heading toward a sustainable, these in fact could be, it actually did work, could be part of a future evolution of our energy systems. Thanks very much.